Hi everyone, in this video I will give you two examples of doing independent tests. Independent test, and we're doing examples. Okay, so in last video we talked about the methods, and in this video I'll do two examples to demonstrate to you. So example one. So we want to ask the question whether male has a different reading speed than female. Okay, so male and female reading speed, and whether they're different. Okay, whether they're different. Okay, we're interested in this. So for male, we collected some samples, and 1 equals to 25, x1 bar equals to 45, sigma 1 hat equals to 15, right? Sample size, sample mean, sample standard deviation. For female, we have n2 equals to 9, x2 bar equals to 70, sigma 2 hat equals to 12. Okay, so we have two sets of samples, male and female. In this case, we're going to do a two-sided test with alpha equals to 0.05. We're going to do a two-sided test with alpha equals to 5%, 0.05. So the next question we should ask ourselves is whether we should use conservative or the pooling. Okay. So the question is whether we want to use conservative method or the pooling method. Okay. Okay, very good. Well, then we have to use our rule of thumb and compare these two standard deviations. Okay. So we do the rule of thumb. Okay, and our sigma 1 hat equals to 15, sigma 2 hat equals to 12. Okay, and let's first double this one and then double this one. So let's compare sigma 1 hat equals to 15 to sigma 2 hat that's equals to 1 hat equals to 24. And then, yes, in this case, our sigma 1 hat is less than 2 hat. Then we're gonna use pooling, right? By this definition, we're gonna use pooling, and then we do another one. Okay. Now, in this case, I'm gonna keep sigma 2 hat equals to 12, and then sigma 1 hat equals to 2 sigma 1 hat equals to 30. So again, sigma 2 hat is less than 2 sigma 1 hat. This gives us pooling, so the decision is pooling. And then since you get both decisions says pooling, then here we're going to use the pooling method. Okay, the pooling method. Good. Okay, very good. So if we're given variances, then here you should multiply by 4, and here you're going to put your variances. Okay, so since we're given standard deviation, there's no need to get the variance and then do the rule of thumb. Okay, then let's get the standard error from here. Okay. Okay, standard error. Now we can just apply the formula equals to. So I'm going to write the formula out first. Squared and 1 minus 1. And 2 minus 1. So this is the formula, and we just put in some numbers. Okay. Segment 1 hat, it's 15 squared, and then sample size was 25 minus 1 plus sigma 2 hat squared, so it's 12 squared. Sample size was 9 minus 1. Okay, then we're going to divide it by 25 plus 9 minus 2. And then we're going to multiply 1 over 25 plus 1 over 9. Okay, and I'm going to take a big square root for this. And then with some calculation, I got 5.5603. This is our standard error. Okay, very good. Now we have our standard error that we can jump into our test statistics. Test statistics. Okay, equals to observed minus expected and over our standard error. Okay, so in here, let's say that the male's mean, the male sample mean is our observed value, and then we want to test whether it's different than the female sample mean. So our female sample mean will be our value to test or the expected value. So here we have 45 minus 70 divided by the standard error, which is 5.5603. And that's going to give us minus 4.496. Okay, and this our test statistics. Now our test statistics, the next step is to find our critical value, and then we do the comparison. Okay, so let's do our critical value. So the critical value, we're doing a two-tailed test. So two-tailed test, and the alpha equals to 0.055%. And since we're doing pooling, so the degree of freedom, in this case is N1 plus N2 minus 2, that's equals to 25 plus 9 minus 2, that's equals to 32. That's our degree of freedom. And then we're going to use our t-table. The critical value we get goes to plus minus. So you can look at the positive side or the negative side, 2.037. So we have our test statistics and our critical value. Now we can do the comparison. Okay, so for our test statistics, right, test statistics in absolute value equals to 4.496, and this is greater than, let me put it here, this is greater than the absolute value of 2 point, or let me just say 2.037, that's equals to absolute value, critical value. So since the test statistics is greater than critical value, and what we're going to do, we're going to reject the null hypothesis. Reject the null hypothesis, right? And then the null hypothesis is the no difference hypothesis. So under the null hypothesis, we're saying that the male's reading speed and the female reading speed, they're the same. Since we reject the null hypothesis, the conclusion is male and female are likely to have different reading speed. Okay, so they're likely to have different reading speed. Okay, so that's how you do an independent test under the pooling method. In example 2, I want to give you an example that we're going to do independent test under the conservative method. Example 2. Example 2, we're interested in, do people drive more on weekdays or weekends? On weekdays or weekend? Okay, so that's the question. Okay. Yeah. So let me say that. Okay, yeah. So in this case, we have weekdays information. Weekdays. And 1 equal to 6. So we ask people how many times you drive in weekdays. The numbers you get are 20, 40, 10, 90, 50, 30, and your X bar in this case is equals to 40. Okay, and then for weekends, you have n equals to 5, so you ask 5 people, and then get 30, 20, 15, 25, and 20. Your x2 bar equals to 22. Okay, and in this case, let's assume that this is all the, oh, let me just say you want to do a two-tailed test. Two-tailed test with alpha equals to 0.05. Okay, so in this case, let's say this is all the information that's given to you. And what's missing? The missing value is the standard deviation, the sample standard deviation. Let's say it's not given in this question. But since we have all the data points, we can calculate them. Okay, so now let's get started with finding the sample standard deviations. Okay, so sigma 1 hat equals to 20 minus 40 plus 40 minus 40 squared plus 10 minus 40 squared plus 90 minus 40 squared plus 50 minus 40 and plus 30 minus 40. Okay, so just each data point subtract the mean squared. And then we're going to divide by 5 because n minus 1, 6 minus 1. Then we're going to take a square root of this. And then the value we get is 28.28. That's our third sample standard deviation. Let me do the second one. 2 hat equals to 30 minus 22 plus 20 minus 22 plus 15 minus 22 plus 25 minus 22 squared plus 20 minus 22. The same method, divided by 4. Okay, again because n minus 1, and this gives us 5.70. Okay, we have sigma 1 hat 28.28, sigma 2 hat 5.7. Now we want to decide whether we want to use pooling or conservative. Okay, the question is conservative or pooling? Conservative or pooling? Okay, and that's the question to ask. And let me just rewrite the two numbers. Sigma 1 hat equals to 28.28. Sigma 2 hat is 5.70. And yeah, and just say we square this one. 2 times sigma 2 hat equals to 11.40. And sigma 1 hat equals to 28.28. This is bigger than 11.40 equals to 2 times sigma 2 hat. Okay. So as you can see, one of the sample standard deviation is bigger than 2 times the other sample standard deviation. By our rule of thumb, we automatically decide we're going to use conservative method. Okay, we're going to use the conservative method here. Okay, very good. So let's see, we're going to keep going. So we're going to do the conserved method because sigma 1 hat is bigger than 2 times of the sigma 2 hat. Standard error we're going to do, standard error equals to sigma 1 hat squared equals over n1 plus sigma 2 squared hat equals to, over n2, that's equals to 28.28 squared over 6 plus 5.70 squared over 5, right? And 1 and 2. Take the square root of this. It's going to give us 111.825. This is our standard error. Okay. Once we have the standard error, then we're going to find the test statistics and critical value. Okay. Our test statistics, in this case, equals to 40 minus 22, right? So we assume, say, the male is the, not the male, it's the weekday is the observed, and then the weekend is the value we want to test. And this divided by the standard error, which is 11.825, and that's equals to 1.522. That's our test statistics. Okay. Next, we want to find our critical value. Critical value, we're doing the two-sided test, or two-sided two-tail. Alpha equals to 0.05, and then degree of freedom is n, the smallest, minus 1. So in this case, the smallest of the two is 5. So it's 5 minus 1. 5 minus 1 equals to 4. So our degree of freedom is 4. So by checking the t table, critical value is equals to 2.776 or minus 2.776. Okay, we're compared to 1.522. Okay, and then the test stats, in this case, in absolute value, equals to 1.522, and this is less than 2.776, which is the absolute value of the critical value. So our test statistics is less than our critical value. What it means? It means we're gonna fail to reject the null. And fail to reject the null would mean the conclusion is driving rate in weekdays are likely equal to driving rate in weekends, right? So we cannot tell if they're different, okay, by our sample. Okay, very good. So this is an example that we're going to use the conservative method to do our independent test. Okay, this video gives you 2 examples, one for the pooling method, one for the conservative method. Thank you for watching.